Okay, good morning, good afternoon, and good evening, everyone. So this is myself, Dr. Ganesh Chandrasekaran, and here with me we have Saheer, Kurva, and Zishan, who will be presenting on the scalable VM backup and restore for large scale KubeVirt deployments. So specifically, we will be focusing on how we migrate, or what is our journey when we migrated from agent based to agentless architecture. So we are with Samsung R&D India. So our team is responsible for managing 50,000 VMs that are distributed and located all across India with 138 data centers and almost over 3.5K bare metal servers. So why are we hosting these VMs is to provide a telecom service to one of the largest telecom operator in the world. So our team manages the orchestrator, which manages the life cycle of all these VMs. These VMs, in order to provide a specific telco service, they are grouped into virtual network functions, which we also refer as VNF throughout these presentations. So out of many functionalities that our orchestrator have in terms of managing these VNFs, monitoring them, identifying the performance and fault, and we also do backup at large scale. So throughout this presentation, we are going to be discussing on how we backup 50,000 VMs without breaking the matrix, which by meaning network. So this is a quick agenda on what all various topics that we'll be covering. So starting with, we will go and explain about the agent-based reality and why it wasn't
Ganesh,
sustainable for a yes.
the slides are not progressing on our side. We're still seeing your title slide. Okay, there we go. There's the agenda.
All right, so I'm not gonna do the full screen, so I'm gonna keep it like this, so that doesn't happen. Yeah. All right. See, coming to the agenda, so we'll start with the agent-based reality on how what issues we are facing with existing agents, and we're gonna discuss some of the telecom-specific requirements that we have and why we migrated into an agentless architecture with the use of KubeVirt. We'll also be presenting the technical architecture behind it, and we'll also guide you through the implementation journey, the real-world lessons, and the best practices that we have learned via this journey. And we'll close the session with some simulation results and 5 key takeaways that you can understand specifically when we talk about large scale backups. Okay, over to you, Sahir.
Hi all. Uh, Hope I am audible.
Yes, Sahir. Yeah.
Okay. Yeah. Actually, our journey with VNF means virtualized network function started during our implementation of 4G components. At that time, European Telecom Standard Institute (ITSI) released specifications for implementing network function using VMs. So we went ahead and implemented our 4G solution with VM and continued the VM-based solution in 5G also. So with this implementation, we got requirement for backup and restore, and we implemented it with VM framework. And initially, everything went well, and VM-based solutions accepted in telecom by telecom providers because there was very stable orchestration framework that we got. It is OpenStack, and telecom operators were saving big on hardware requirements. So everything went well. We implemented an agent-based backup and restore solution, and we tested and deployed in multiple countries, around 20 customer base. Everyone was happy. Then we got one customer where we needed to deploy this backup solution to manage more than 5,000 VMs at one data center. Then the problem started coming. So our architecture was, we had a manager in the orchestration module, and we implemented agents in every VM as well as every host in the host that hosting the VM. And the communication between the manager and these agents were through REST APIs, and we were releasing the agent as well as the manager module during every development life cycle. When we started managing thousands of VM, the operation became a hurdle. Means every logging into every VM and putting the agent there itself became a huge effort. The operational cost of that was very high, and this gave a further problem when there was any OS upgrade or if there is any shelf life end of any of the component. We were forced to go through the development life cycle again, test again, then release to the customer, then again upgrade or deployment. It became a big headache. We'll move to the next slide. Ganesh, can you move to the... So ultimately, we end up spending more time managing backup infrastructure than protecting our data. So actually, in telecom domain, the requirement related to backup and restore are very stringent. We need to maintain a stringent level of security requirements. HIPAA is there in Europe, and even strong security encryption is required in all of the countries. And then we had a very strict requirement related to high availability. Means the all services need to be available 99.9999, means five nines. So the restore operation should need to be very fast. We cannot compromise on any of the services if there is a restore is required. And we had a very high requirement related to the usage of agent in the VMs, backup agent in the VM, consuming hardware resources like CPU, network bandwidth. Many of the time when the VM images are image backups are taken, we found that it is hindering the VNF's functionality. It is taking a lot of network bandwidth. Even though we implemented incremental backup using LibVirt features, it didn't resolve when the scale is high. So after this, ETSI released CNF's spec. Now network functions are moving into container. So we had a rethink on how we can improve the implementation, how we can improve the design to scale it high and move it into container world. So we moved from agent-based container backup solution to agentless backup solution that helped us to scale. I am handing over to Kuruva. He will explain how the scaling is done.
Hi, all. I'm Kuruva. So in the agent-based backup, like we have multiple agents was installed in multiple places. So in case of agentless backup, backup and restore manager, which will directly communicate via Kubernetes API server, and it uses the inbuilt supported features like snapshot and KubeVirt features. So we don't require to implement new additional things. So in order to take a backup, so which will simplifies the backup and restoration process, which also enable us to focus on automating the backup and restoration process using our custom CRD. And also like we are also using like Kubernetes based native RBAC authentication and events in order to take a backup and restore and monitoring alarm purpose. So here we are reusing our Kubernetes API supported KubeVirt features itself. Yeah, can you move on next slide? Yeah, so here this is a VNF composition of like mobility management entity and virtual gateway and like that several other VNF. Each VNF virtual network function so consists of different kind of VMs. Here all active nodes will be resides on active node, one node, and standby VMs will be reside on like other compute nodes in order to provide HA between these two nodes. And each VNF will have different types of VMs. Like if you see like management purpose, some VMs and user and data purpose and even application purpose and DB function purpose, we have each type of different types of VMs and it will have different kind of redundancy. like whatever that Kubernetes, like KubeVirt backup API, whichever is supporting, which is not sufficient to take telco specific VNF backups and all. So that is the reason. So we have implemented our own custom CRD. Like here, if you see that here each VNF will have different set of active and standby node. So we are grouping all active nodes as a one set of grouping, and while taking a backup of active node, we will do the switch over, make sure that to have the consistency of the data, and after switching over, then we will just verify once again. We will take a backup of active nodes and like that. So we used to have the backup of all VMs. Like here, if you see that in file level, backup level, we have different kind of backups like VM backup, snapshot, and database level, and even file system level and configuration level, and like even VNF level, some backup and restoration and cache backup level. So in order to take all these kind of backups, so and that is the need of, we need to have our custom CRD. So that is the reason we have developed our own custom CRD. So in order to achieve the telco specific whatever CRD, that if you see that sample, that definition here, this is for example for vGateway U, like that each VNF we have different kind of custom CRD. Like using this, we used to have VNF level backup using our custom own CRD. Using like this, we have implemented our own CRD based on that VNF specific redundancy level and all. So now next hand over it to Jishan. He'll be taking it.
Yes. Hi everyone, I'm Dishan. Now let's dive into some of the best practices and key insights we gained from experimenting with agent backup strategies and backup and restore strategies on KubeVirt. And hopefully there is something interesting for you as well. So for scaling backups up to the 100, more than 100 sites, we have planned resource allocation, and this limits the resource such as CPU, memory, etc. And resources can only be requested within those limits. And this operation is per backup operation. This limitation is to ensure that backup don't overwhelm manager nodes. We use few techniques for network optimization as well. We run up to 8 parallel backup strings per site. Local staging combined with WAN optimization ensures faster backups and efficient data transfer across remote sites. And we also make use of bandwidth throttling on off-peak hours or as per the schedule and as per our requirement. Now, the next best practice we have also achieved reduction in the impact on resources. The CPU consumptions are now capped only at 25% on hypervisor nodes, and the absence of backup and restore on VMs ensure memory is also isolated. VMs could be the VMs in question for backup, also the hosts which are holding those VMs. Now, like mentioned in the previous slides, we have various types of VNFs for which we need to define different kinds of CRDs. So for one kind of VNF, we could have application-aware backups, and for another kind of VNF, we could have incremental backup strategy. So for, let's say, for application-aware backup, we make use of a declarative approach using CRD to define a backup policy. And here we can schedule backup with application level consistency. For example, in this case, we see that for MySQL, it is that defined the schedule is also given, and what script has to be run for pre and post snapshot hooks are also provided, so that we ensure that data DB is also consistent, DB data in the DB. Yeah, and since all the jobs are handled by Kubernetes, for this, all the services are now orchestrated by Kubernetes. So this also helps us reduce the manual interventions. So because of this, our manual intervention comes down to zero. Overall, we have seen the reduction up to 75% in application recovery time, and also application level consistency ensures that data is not corrupted. Since we have a little bit on time, I will just quickly cover the few topics. Like for the, yeah, okay, I will, yeah. Now coming on to the quantified results here, Here, actually, we have this is done in a simulated environment, and agent versus agentless based um, comparison is there. So we have captured multiple matrices here, and few of the matrices, let's say, which we are presenting is VM overhead. So most importantly, the VM overhead with respect to the resources the agents used in the VMs, whether the host VMs or the VMs which has to be taken backup of, the resources are now reduced by up to 80%. The network usage reduction is down by 95 to 59% because of various optimization technique which we employed, like fan optimization, bandwidth throttling, as well as parallel backup streams. Other than that, like operation cost also reduces because we don't have to manage agents, and we don't have to manage the installation of agents on the VMs, and that is also a major reduction. And failure rate also reduces because now we have reduced the components, we have reduced the failure points, so our failure rate has gone down by 83%. Yeah, over to you, Ganesh.
Yeah. Thank you, Zishan. Okay, coming to our final slide, where I would want to just summarize the key takeaways. So, moving on to Agentless, KubeVirt and CSI APIs provided the technical foundation for us to move into an agentless based approach for our backup and restore. So, since scale is one of the key metrics, we started planning for the scale from day one, and we incremented our growth in scale by 10x just on relying on this Kubernetes and KubeVirt and CSI based APIs. And regarding to the network optimization, I think this is the second session about backup and restore. I think the first one where Shelly covered about the incremental backup approaches. It's very good to know that KubeVirt in the moving forward, KubeVirt itself will have its own incremental backup approaches that can be utilized. But for now, we are relying on various CSI providers on how we could take incremental backup approach and local staging. So these two technical attributes are like game changers in terms of reducing the network optimization. So with previous agent based approach, we used to have a schedule time, or the orchestrator used to poll, understand the network situation by interfacing with multiple or SDN controllers or the redfish APIs. But however, moving on to incremental backup, so the elimination of those were also done. And next is the API driven approach. So leveraging Kubernetes native patterns by creating our own CRDs to meet each specific VNF's requirement. So we were again able to automate and kind of have a fine control on what data we want to back up, how we want to back up. Is it only a specific database, or is it just part of some configuration stored in some config maps, or is it part of some specific catch database that we want to take? So we were able to fine grain the specific requirement of a certain VNF and tailoredly create our own CRD for our needs. And finally, observability comes inbuilt when we were using KubeVirt and CRDs, Kubernetes based approaches. Because in the previous agents, we used to monitor all of these data via multiple interfaces, but now we're moving on to agentless via KubeVirt. All of them are comprehensively available as part of our CRDs. We can write it as part of CRDs, and also it can be monitored via other monitoring agents. So that brings down to the last slide, and thank you for all your time for listening. If there is any questions, I think we will answer on the chat session as well.
We're at time. There is just one question, if it can be answered really quickly. It's which CSI driver do you use that has support for incremental backup already?
Okay, so currently we work with multiple CSI providers, but I think I'm not sure if we're supposed to disclose any specific ones, because it's part of all licensed ones. So they're part of licensed ones. So that's something that we don't want to disclose. But I think moving forward, relying on KubeVirt would be a good alternative.
Awesome. Thank you very much. That was wonderful.